In this video, we're going to look at muscle at a microscopic level, and I hope that you will agree by the end of the video, you'll just be amazed at how complex muscle is at this microscopic level, and more so how amazing it is that we're able to control our bodies, more so even how amazing it is that dancers are able to perform the movements that they can perform by controlling the muscles and coordinating their muscle contractions to produce the beautiful movement that, of course, they are so good at. So remember that this microscopic structure of muscle is common across all muscles within the body. So if you can understand how this microscopic structure works, then you can really understand how the fundamental unit of muscles can help to produce the force and the movement that dancers need in order to dance. So let's have a look at this first picture on the left hand side to start with. So if you remember from the previous video, we were looking at muscle at a macroscopic level, and the muscle fiber that we can see here was the smallest unit that we dealt with. Now, a muscle fascicle is really just a bundle of muscle fibers, and a muscle itself is really just a bundle of muscle fascicles. But what we're looking at for this video is what we refer to as the contractile elements, or I referred to them as the active elements because they're the parts of the muscle that actually use energy to produce force and to produce movement. And the muscle fiber is the cell of the muscle. So it is the functioning living cell within a muscle. And you can see here that it's wrapped up by this sarcolemma, and that it's comprised of these big long strings of what we can see here as sarcomeres. And sarcomeres are the primary functional unit of muscle. They're tiny. They're microscopic in the fact that if you lined about 4,000 of them up end to end, like you can see along here, this would equate to about 1 centimeter's length of muscle. And then you can see here that we've got thousands of these lengths of sarcomeres within each muscle fiber, all wrapped up together to produce a muscle fiber that can then, of course, produce force and movement. To look a little bit deeper and to focus in a little bit more, each sarcomere here is the length of between two of these green lines and is comprised of what is represented by one of these purple lines here. So if we look across to the next image in the middle here, you can see that we've got these common zigzag green lines here. And in the middle, we've got these purple lines. And you can see that that refers to one sarcomere. So one sarcomere is just effectively one of these purple lines bound by this green structure. And they're the two fundamental elements of a sarcomere. They are what we refer to as actin. So you can see actin is written here. And then the purple here is what we refer to as myosin. So actin and myosin are the two main components of each sarcomere. Now, a good way to think about actin and myosin is actin is the framework. It's like the scaffolding of the sarcomere, whereas myosin is effectively the engine. Myosin is the bit that uses energy and ultimately produces the movement. And just to jump across to the right-hand slide here, really all that actin and myosin do is that myosin uses energy and it pulls actin together. So you can see here in the top, image 1 on the right here is a little bit longer. So if we were to measure this length along here, it's a little bit longer than image 2. And really the reason that it is longer is you can see that this gap here between the ends of the actin is greater than the gap here represented by the H in image 2. So for a muscle to contract, for a muscle to produce force and to produce movement, then effectively what myosin does is it pulls actin together. Now this is a really important concept for understanding the way a muscle is structured, because if a muscle wants to use energy to produce force and to contract, it can only do so by shortening. A muscle cannot create movement by lengthening. The only way it can produce movement is by shortening. Now, there's a little tweak to that that can stop itself from lengthening, and we'll look at that in further videos. But the primary thing about this video here is that muscles can only shorten. If a muscle is going to use energy, it can only produce movement through using that energy by shortening. So how does it do that? Well, you can see here, remember we've got actin in the middle here. Actin is our framework and myosin is our engine. And you can see myosin is comprised of these two sort of structures here. We've got what is called the tail. So you can see we've got tail written here, and then we've got the heads. And it's what it looks like. It looks like a couple of heads stuck to a tail. And the basic way that myosin is able to draw actin together is that it will link up, if we go across to the right hand side, it will link up to actin, and this head here will pull in this direction. And in doing so, it's like a little finger grabbing onto actin and pulling it closer. And you can see here along the myosin chain, we've got lots and lots and lots of myosin heads. So each of those heads is capable of using energy and producing force and pulling on actin. So the microscopic structure of a sarcomere, the foundational way that a muscle is able to produce movement, is by myosin heads connecting up to actin and squeezing actin together. Now think about how many thousand sarcomeres, how many thousand myosin heads you have in each muscle fiber, going out to the thousands of fibers in each fascicle and the thousands of fascicles within just one muscle. And it's mind-blowing to me that we're able to actually produce reliable and coordinated movement by coordinating all of these thousands and thousands of little structures together to produce human movement.